Welcome everyone to today's Explainer. Look, if you're a procurement manager, a facility engineer, or really anyone tasked with specifying electrical infrastructure these days, you already know the stakes have absolutely never been higher. Today, we're tackling a massive core challenge in the industry, and that is evaluating electrical cable tray suppliers. I mean, it sounds pretty straightforward, right? You need parts, you find a supplier, you place an order. But the reality of modern infrastructure demands so much more than just a simple transaction. Today, we're moving way beyond the catalog to understand what actually separates your average, everyday vendors from true engineering partners. Okay, let's dive into this, because we really need to ask the ultimate litmus test question right out of the gate. Can your supplier actually verify performance? We so often fall into what I like to call the catalog trap. You know how it goes, we get a beautifully designed PDF, we find a part number that seems to kind of match our specs, and we just assume it's going to work perfectly. But honestly, the catalog trap is incredibly dangerous. When we rely solely on a printed number, we're essentially taking a massive leap of faith. We're assuming that standard baseline testing will somehow miraculously cover our very specific, highly demanding real-world applications. We really need to challenge our current procurement habits right here, right now. Ask yourself, are we buying a promise or are we buying verified physical performance?
So that brings us to Section 1, Beyond the Part Number, or as we just talked about, the catalog trap.
There is just a stark night and day contrast between these two types of suppliers. First up, we've got the catalog vendor. Their primary function? Quoting a part number. It's basically an administrative task. It's fast, it's easy, and it requires virtually zero engineering overhead on their end. But then, on the flip side, we have the engineering-capable supplier. Their mandate is entirely different. They verify real-world conditions. And guys, this distinction is literally everything. Why? Because standard catalog promises are broken by real-world physics every single day. A glossy catalog doesn't know the exact environmental stresses of your specific facility. It doesn't know your weird installation constraints. An engineering-capable supplier looks at the actual physics of your project, the gravity, the environment, the structural realities, and mathematically verifies that the system will hold up under those exact conditions, not just in some theoretical vacuum. Let's move to and see how this builds into Section 2, the 2026 Capability Framework, which is all about the engineering metrics. If you want to know for sure if you're dealing with a truly capable supplier, you've got to apply the rule of 3. Step 1, verify span. Step 2, verify load. Step 3, verify corrosion environment. It's a really simple but incredibly rigorous physics-based evaluation framework. Most suppliers out there can quote you the part, sure, but very few can mathematically and empirically verify whether that specific part number will actually work at your exact span requirements. Even fewer can verify it against your specific physical load, and fewer still can guarantee it's going to survive your exact corrosion environment over the long haul. Span, load, corrosion. If a supplier cannot hand you hard, verified data on all 3 of these metrics for your specific use case, well, they're a catalog vendor, not an engineering partner. All right, moving right along to Section 3, enter Xinma, which is honestly the ultimate case study for this whole concept. Now, what's really interesting about this slide is the sheer breadth of their manufacturing capability. Shanghai, Xinma, Busway, and Cable Tray Co. Ltd., or just Xinma for short, they aren't just stamping out generic metal trays. They're engineering comprehensive infrastructure solutions. We're talking advanced cable tray systems, high-capacity busways, absolutely critical seismic bracing, and highly sophisticated intelligent cable management solutions. This core identity is so vital. Think about it. When a company is engineering seismic bracing right alongside intelligent management systems, it tells you that their internal engineering culture is rooted deeply in real-world physics, structural integrity, and advanced performance. They aren't just selling parts out of a box, they are architecting safety and reliability. Which leads us perfectly into Section 4, high-stakes industries served, where performance literally matters most. Look at how these advanced product lines map directly to some of the most intense, demanding target industries on the planet. Cable tray systems and intelligent solutions, those are absolutely mission critical for data centers, where uptime is literally measured in fractions of a second, and heat load and cable density are just off the charts. Then you look at rail transit and industrial plants. These wild environments require super robust busways and heavy-duty seismic bracing to ensure that even under immense vibrational stress or a catastrophic event, the electrical lifeblood of the facility doesn't skip a beat. Finally, you have massive commercial buildings that require flawless integration of all these systems just to maintain safety and efficiency at scale. Xinma's product matrix is specifically engineered to thrive in these high-stakes, absolutely zero margin for error sectors.
And finally, Section 5, Global Compliance Standards, the actual documented proof of capability.
And this brilliantly illustrates exactly how engineering credibility is proven on a global scale. We aren't just taking a supplier's word for it here. We are demanding rigorous, internationally recognized compliance. Xinma's products comply with IEC 6157 for cable management, NEMA VE1 for metal systems, BSEN 50085 for trunking, and GB 3125. Now, I know we don't just rattle off these specific alphabet soup acronyms to sound smart. Actually, meeting these standards means their products have been subjected to and survived the most punishing testing protocols in the world for span, load, and corrosion resistance. This is the documented, indisputable proof of their engineering capability. No guesswork required.
So, the crucial point is this: evaluate engineering capability, not just catalog numbers. Whether you're an electrical engineer designing a next-generation data center, or you're a procurement manager sourcing for a major new rail transit project, your job is to look past the shiny PDF. You absolutely must demand verification. You have to demand a supplier who understands your exact span, your specific load, and your unique corrosion environment. Suppliers like Xinma represent the benchmark for this, exactly because they operate as an engineering partner fully backed by global standards rather than just a mere vendor pushing standard part numbers.
I want to leave you with this one final thought to really reflect on today. Take a hard, honest look at your current supply chain and ask yourself, are you just buying from a catalog, or are you truly engineering for the future? The reliability, the safety, and the longevity of your entire infrastructure depend entirely on how you answer that question. Thank you so much for joining me for this explainer, and I highly encourage you to start applying this 2026 capability framework to your very next project. Catch you next time.